Now that we have the primitive wrapper classes, we can take advantage of the capabilities that all classes have when working with our primitive types. For example, we can now treat our primitive types as object. So if we have a situation where we have maybe an object array or any other type that expects object references, in addition to putting in things like a reference to a flight class or a passenger class, we could even drop in a value like 100. Right? What happens in this case is that Java will go ahead and get a reference to an instance of the integer wrapper class with a value of 100 and assign that reference into stuff sub2. We also have the benefit of null references, so we have a distinct idea of a value not being set. Let's take a look at our flight class here. Our flight class, as you recall, has an int for flight number and a char for flight class. So inside of our toString method, we said, well, if flight number is greater than 0, we go ahead and return back a string containing the flight number. Of course, the idea there is that we're saying that, well, if the flight number is greater than 0, we know it's been set. But we make the assumption that if it's not greater than 0, it must not have been set, even though it's potentially possible to have a flight with a flight number of 0. And then we also make the assumption that, well, if flight number is not greater than 0, well, you must have set flight class, because we don't really have a distinct way of knowing that the values haven't been set. But if we now convert our int and our char to their wrapper class equivalent, so we take flight number and we make that an integer instead, we take our flight class and make that a character instead. Now we go inside of our toString method. We want to check and see if flight number has been set. Rather than checking to see if it's greater than 0, we can check to see if it's not equal to null. If it's not equal to null, we know it's been set, no matter what value is inside of there. When it comes to checking the flight class, rather than just assuming that, well, flight number wasn't set, they might have set flight class, we can actually check and see if flight class is not equal to null. So that now gives us, instead of just 2 states, you've set one or the other, we have 3 states. You could have set one, you could have set the other, or maybe you didn't set anything at all. So we're getting that benefit that we've had with our classes all along, now with our primitive values. Now, as we mentioned, the wrapper classes provide members as well. Let's take a look at just a few of those. So I have here on screen a list of just a few of the members in each of the classes. If you look at the integer classes, byte, short, integer, and long, you see that we have things like min value and max value, which are fields that tell us the bottom range and the top range of that each type. A method like bit count that lets us see the individual bit values in an instance. Or things like toBinary string that lets us get a string back with the binary representation of an instance. On our floating points, we have min value and max value, again for the bottom end range, top end range. But notice it introduces concepts like infinite, or not a number. On character, once again we have a minimum value and a maximum value, but then we also have things like is digit and is letter to see what kind of character is inside of a given instance. And then on Boolean, we even have fields for representing a reference to a true instance or a false instance. Now these members I have on screen here are just a tiny, tiny sampling. To see the complete list of members, over there on the right-hand column, I have a shortcut link to the documentation on each individual class. Check those out when you have a chance, and you'll see there's actually a lot going on with each of these individual wrapper classes.